Hi everyone, welcome to today's video where we are going to learn how to disintegrate static meshes with multiple materials. This works as a continuation of the previous tutorial video where I had demonstrated how to create disintegration effect for a static mesh with a single material. In this video we will start by setting up a base material integrating the dissolve functionality that we created in the previous tutorial. Then we will modify the actor component to ensure it works with multiple materials, and next we will create a small C++ code snippet to retrieve the triangle information of the given material section, which we are going to pass into the Niagara FX system. And finally we will create a custom Niagara module script to receive the triangle data and sample the static mesh accordingly. So let's get started. For today's demonstration I will be using two different meshes from the engine's content directory. These meshes will serve as a good starting point to understand how multi-material disintegration works. Let's now duplicate the Niagara system that we created in the previous video. We need to change the static mesh to this one. And I don't need this additional emitter, so I'm going to delete it. I will just open this mesh and see the material sections. So these are the different sections that this mesh is comprising of. And we are going to spawn the particles in each of these individual sections. Now, if you want to avoid all the hard work and manually want to assign the material slots, there is a quick way to do this. In the section filter over here, you see the allowed material slots. So you can just add indices representing the material slots where you want to spawn the particles in. I also need to change the triangle sampling mode from random all triangles to random section filter. Yeah, now only the material with the material section index 2 is being sampled. This can be a perfect and quick solution for your multi-material disintegration, but you need to do this manually because there is no way of assigning a variable into it, and that's why you cannot control this from blueprint. Let's change the materials for the mesh because it is just having this world grid material. This material is going to serve as the base material. Let's make a couple of instances and assign them to the respective slots. So this is a simple and minimalistic material setup that we have here. So this is the material that we were using for the dissolution in the previous tutorial. So I need to copy this over and paste it in the current material. This makes this material a perfect base material that we can create instances out of and apply to any static meshes or particles whenever we need the dissolution effect. So now let's look into the transition actor component that we made in the previous tutorial. Here you have noticed that I am only using a single material slot, the first one. So in the case of multiple materials, we need to use a for loop. So for the mesh component, I will get all its materials. This is going to be an array, and this entire section of sequences is going to come inside the for loop. So let me first set this into a variable. I will just walk you through this sequence of actions once more. First, we are creating the dynamic material instance for the mesh and setting the dissolve alpha value, which is 0 initially, and then assigning the material to the mesh. And we are doing the same thing for the particles. And here we are spawning the Niagara system. So here I'm going to use this for each loop. First, I will set the array element as the current material, and I also need to set the current array index as a variable because this is going to determine your material slot index, and I have to assign that over here. And since this is happening inside for loop, there are going to be multiple dynamic material parameters for both the mesh and the particles. So we need to create two arrays. Variable type is material instance dynamic. One array is for the mesh dynamic materials and another one is for the particles. So I will add the current dynamic material instances to the respective arrays. And I will also make changes in the tick event where I want to set the parameter values for each of the material instances in these two arrays. So I need a couple of for each loops. Let me add a sequence node because it's easier to connect the two for loops in two sequences. Okay, so this is the second for loop with the particle materials. So this is going to spawn the Niagara system for every material slot. But how will the particle know which slot a given Niagara system is going to spawn in? Because here we just hard-coded the value and there is no way to assign a variable over here. So we cannot control this in Blueprint. Now there is quite an obvious way of doing it. Let's say your mesh is only having 3 material slots. So all you need to do is create 3 different static mesh user parameters, create 3 different emitters and assign each of the parameters to the respective static mesh location module. And for each of the parameters, you are also assigning the unique material slot. But that is going to be quite a lazy way of doing it. Being a programmer, I always prefer to create a solution that can work across multiple different types of usages and scenarios instead of manually hard coding things. So here I'm going to create a new C++ class. It will be Blueprint function library because I just want to create a static function that can be called from Blueprint. In here, I'm going to create a U function. This is going to be Blueprint callable because I want to make it exposable to Blueprint. And I'm going to create an array of in32, which is basically the array of triangle indices belonging to the corresponding material index of the mesh. Get triangle indices for material slot. I need to pass the mesh component and the given material slot index. And I also need to pass the LOD index because material slots can often vary across multiple LODs. We'll start with defining the array of triangles. And if the mesh is valid, we take the reference to the static mesh. Here we are going to check for another validity for the static mesh rendered data, and we are going to take the reference for the static mesh LOD resources because this is where all the material section data is present. So let's write a for loop for all the sections of the LOD, and if the section's material index is matching with the material slot index that we are passing, then we are going to get all the triangle information from there. I will need another for loop here to get all the triangle indices of the section. So in our triangles array, we are going to add the current triangle index, which is not going to start from 0, but rather the first index of the section. Here you need to understand something. The indices present in the section are actually not the triangle indices, but rather the vertex indices. Every 3 vertices are connected together to form a triangle. So for example, if a section is having 6000 vertices, so it means it is going to have 2000 triangles. So I need to divide the section's first index by 3. And finally, we are returning the triangles array. One more thing here, instead of static mesh component, I decided to pass the parent class, which is mesh component, because in the future videos when we are working with the skeletal mesh component, I also have to use the same function to work with skeletal mesh as well. So I will just do a condition check. If this is static mesh component, then our current code block is going to execute. And when we work with the skeletal mesh component, then I will add the new code block in this same function. And in the blueprint also, if you remember, we are using the parent mesh component itself. Okay, so I'm getting a compile error here. That is because of the sign mismatch. The parameter section.numTriangles expects u in 32. So I will just change the variable type of the triangle index to u in 32. Okay, so this should work now. Alright, so let's call this function get triangle indices for material slot. I will pass the mesh component and the current material slot index. I will have the LOD index 0 for now. So I'm going to save the triangle indices into a variable. This is the variable we are going to pass into the Niagara. We are going to create in 32 array. I will name this as triangles. I don't need the material slot for now. We need to create a module script. New scratchpad module. Here we are going to pass the in32 array, which is going to be our triangles, and I need to set the current triangle ID, and the namespace is going to be particles. So for every particle I'm going to choose its own triangle. So let me call the get function, which is going to return a given element in the array. We need a random index, so I will use calculate random range integer. Integer mean is going to be 0 and integer max is going to be the length of the array minus 1, which is basically the last index of the array. Convert numeric to int32 and this is going to be 1. I will click on to apply scratch. This gives me a random triangle index for every particle. So for the indices input, I will read from new user parameter and I'm going to assign the triangles parameter. So this needs to be dragged before the static mesh location and I will rename this to something like get triangle index. And here I will add direct all triangles. This expects a triangle ID, so I will add the triangle index that we are getting from our module script. And here I will pass the Niagara set in 32 array. The variable name is triangles and I will pass the current triangle indices in the array data. So let's check this out. Okay, so all of them are spawning at once and it is not quite prominent if our code for the section is working correctly. So I will just quickly check that by adding a condition. If this is equal to the last index, then only it should work. Branch. Yeah, seems to work fine. The particle count was too high, so I will reduce the spawn rate over here. Let me also disable the forces for now, just to get a better understanding of if the particles are correctly distributed to the respective mesh section. Okay, so now we are satisfied with the result because at least our C++ code is working correctly and the particles are properly spawning in the respective mesh section. So now I will just remove the condition. Yeah, so this works. Currently all the forces are disabled, so we can properly visualize the mesh sampling. Let me enable the forces back. Okay, the dissolution itself is not looking great visually, so we can tweak the material parameters. So when the dissolve UV blend is set towards 0, it is taking the world position as you had already seen from the previous tutorial. And that does not always create better results. So try to adjust the UV blend. Yes, this looks much better. We can further adjust the forces till we get the expected outcome. Okay, this will do for now, and before we tweak this any further, let's work with the second mesh. We first need to add our disintegration material instances instead of the materials currently assigned. So we will try to make the materials as close to the originals as possible. So I'm going to duplicate the base material and adjust the properties. So this is pretty straightforward method. You just replace the textures, you change the colors. Some of the values are not yet parameterized like these ones. So I will just convert these to parameters as well so that it's easier for me to modify them in the material instance. So now I will add the transition component to the actor and choose our Niagara FX asset. Let's also customize the dissolve curve. I will create a new Niagara asset and add that here instead because I may want to have different settings. But typically in most of the cases you can just have a single FX, add as many parameters as possible and then change the parameter values from the blueprint itself. Alright, so I'm done with the changes. So now let's check this out. Yeah, this is perfect. Pretty cool, right? Okay, so that's it for today's tutorial, but we are not done yet. Currently, the material sections are disintegrating all at once. I have not yet added any functionality to adjust the individual section as per your preferences. For example, setting custom delays or custom duration to each of the individual sections separately. That is what I am interested to create in the upcoming video. And here is the interesting part. You need to make a choice. Do you want to learn how to do that in Blueprints, or you are more interested in learning how to do that in C++? The choice is yours. So what will it be?